Your brain generates enough electrical impulses every single day to power a small device, and each spark comes from a microscopic cell firing with absolute precision. Those tiny bursts of electricity shape your thoughts, movements, memories, and every decision you make. Today, we are taking a deep dive into the electrical properties of neurons, the real engine room of the human nervous system. The human brain is often compared to a supercomputer, but that analogy barely scratches the surface. A computer processes electrical signals through silicon circuits. Your brain, on the other hand, processes information through living, adaptable, self-repairing neural networks powered by electrochemical energy. Neurons are the electrical workhorses of your nervous system, and their properties determine everything from reflexes to high-level reasoning. At the core of a neuron's electrical behavior is the resting membrane potential, a voltage difference across the neuron's membrane created by ions like sodium, Na, potassium K chloride, Cl, and calcium, Ca². When a neuron is not firing, it maintains a stable electrical state, usually around -70 millivolts. This is not random, it is the result of selective ion permeability and the sodium-potassium pump, a molecular machine that works non-stop to keep the neuron primed and ready. Think of it as the neurons, charged but waiting, mode. Once a neuron receives enough stimulation from other neurons, it crosses a threshold and fires an action potential, a rapid, temporary reversal of membrane voltage that travels down the axon like an electrical wave. This impulse is the core language of the nervous system. It is fast, reliable, and uniform. Whether you're touching a hot stove or solving a complex math problem, action potentials deliver the message. The speed of this electrical signal depends heavily on two structural features, axon diameter and myelination. A wider axon reduces resistance, allowing electrical impulses to move faster. Myelin, a fatty insulating sheath found in the central and peripheral nervous systems, boosts conduction speed dramatically by enabling saltatory conduction, where the impulse jumps between nodes of Ranvier. Without myelin, neural communication would slow down to a crawl, impairing coordination, perception, and reaction times. Once the action potential reaches the axon terminal, electrical communication transitions into chemical communication. Voltage-gated calcium channels open, neurotransmitters are released, and synapses pass the signal forward. Even though neurotransmitters are chemical, this entire cascade is powered by electrical triggers. Every thought, every emotion, electrical impulses start the process. Another essential electrical property is synaptic integration. A neuron receives thousands of inputs, both excitatory and inhibitory. It must evaluate this massive influx of signals and decide whether to fire its next action potential. This decision-making process happens through the summation of electrical currents, temporal summation, signals in rapid succession, and spatial summation, signals from different locations. Your brain's ability to compute, prioritize, and react originates right here. Neurons also exhibit plasticity, the ability to strengthen or weaken their electrical responses over time. This is the backbone of learning and memory. When synapses fire together consistently, electrical efficiency increases. When pathways go unused, electrical activity decreases. This dynamic tuning allows the brain to evolve with experience, adapt to injuries, and support long-term cognitive function. In the United States, research on neural electrical properties is a major driver of innovation in neuroscience, mental health therapy, prosthetic technology, and brain-computer interfaces. From tackling neurodegenerative diseases to designing AI inspired by biological neurons, this field is shaping the future of medicine and technology. Understanding how neurons generate, conduct, and process electricity isn't just academic, it is foundational to the next wave of scientific breakthroughs. Neural electricity is not just a biological curiosity. It is the core infrastructure of human existence. Every heartbeat, every breath, every creative idea, every memory of childhood, all powered by electrical properties encoded in the architecture of neurons. If you want more deep dive breakdowns on how the brain works at an electrical and molecular level, and how this research is reshaping the future of healthcare and technology, hit subscribe, drop a comment, and stay tuned. Your curiosity fuels this channel, and we're just getting started.